If you look on page 1219, I have some problems identified as challenge problems. These are the hard ones. So when we look at the challenge problems, the harder kind you'll see in the homework and on the quiz and on the test now and then. Usually on a test, there will be 2 or 3 hard problems that are multi-concept problems. So the first ones we did, we said, here's Raoult's law, and then we figured out something using the Raoult's law equation. Now we're going to take the new stuff, Raoult's law, and we are going to do something fancier with it. So let's get fancy. Solution prepared, dissolving 0.144 grams of eugenol in 10 grams of benzene, had a vapor pressure of this. The vapor pressure of pure benzene is 95 torr. What is the molar mass of eugenol? So we're asking about molar mass of eugenol. We're not asking now to rearrange Raoult's law equation. So when you think about this, what units do we use for molar mass? Grams per mole. So ultimately, I need the grams of eugenol and the moles of eugenol so that I can solve this problem. Now, if we go back and read the grams of eugenol, I've got that right here. So that tells me I'm going to need that later. Okay? Now, I know Raoult's law. I know the pressure of the solution is equal to the mole fraction of the solvent, the benzene, times the pressure of pure benzene. When I look at this, I know the pressure of the solution, and I know the pressure of pure benzene. That's information provided in the problem. So I can use this to solve for the mole fraction of benzene. So the pressure of the solution, a number that's provided, divided by the pressure of the pure material is equal to the mole fraction of the benzene. So my solution pressure, 94.35 torr, divided by my pressure of pure material, 95 torr, is equal to my mole fraction, and that is 0.9932, mole fraction of benzene. Now, this gets different than any of the problems we've done before. Now we're going to do something weird with mole fraction that we haven't done before. Mole fraction means moles of benzene divided by the total moles. I know how many grams of benzene I have. I have 10 grams of benzene. So I can turn that into moles. So let's do that. So I have 10 grams of benzene. I know that 1 mole of benzene is 78.1134 grams. So I know that I have 0.1280 moles of benzene. And I know the mole fraction of benzene. But what I want is the moles of eugenol. So how can I use the mole fraction and the moles of benzene to find the moles of eugenol? This is the challenge part. I know that 0.9932 is equal to the moles of benzene, 0.1280 moles of benzene, divided by the total moles, right? So all I have to do now is rearrange. So my total moles is equal to 0.1280 moles divided by 0.9932. So that is equal to 0.1289 moles total. How can I use the total moles and the moles of benzene to get the moles of eugenol? Subtract. So the moles of eugenol is equal to 0.1289 moles minus 0.1280. So I have 0.0009 moles of eugenol. Now, to find the molar mass, I divide grams per mole. So 0.144 grams divided by 0.0009 moles, I only get 1 sig fig, 200 grams per mole. So this was kind of a crazy path. I started off with information and used Raoult's law, but this time I wasn't solving for the pressure of the solution. This time I was solving for the mole fraction. Then I used the mass of benzene to find the moles of benzene. Then from there, I found the total moles using mole fraction and moles of benzene, and then I could figure out the moles of the eugenol. So this is what, like a 4-concept problem? 4 different things you've learned in your chemistry career to try and pull it together. And these are the kinds of problems that will be on the test as the hard ones, or what I call the A problems. If you know the basics about Raoult's law, you're going to pass the class. When you know how to do the fancy, you get more than passing.